For decades, millions of people have feared that sweet corn is a genetically modified and potentially dangerous food. Yet for the rest of the world, sweet corn remains a golden grain, quietly nourishing the global food industry and supporting the livelihoods of countless farmers around the world. So have you ever wondered how billions of cans of sweet corn are made every year? The grand journey of this mighty crop begins in sun-drenched fields, where each fresh ear of corn is carefully harvested and brought to the factory. There, under the hands of skilled workers and the precision of modern machinery, these golden kernels of the earth are magically transformed into a familiar staple of our everyday lives. And every remaining part is also used to create eco-friendly products and nutritious livestock feed. Today, Agriculture Insight invites you to follow the journey of sweet corn. From sun-drenched fields across the land to the secret recipes that have won over the world, everything will be revealed in this video. Imagine standing in the middle of a sun-drenched cornfield, where towering stalks sway proudly in the breeze. Welcome to Minnesota, Washington, and Wisconsin, USA, the sweet corn capital of the world. Every year, the United States not only harvests up to 3 million tons of sweet corn, but also dominates global field corn production with a staggering 380 million tons, grown across farmland as vast as the entire country of Germany. America's scale is so overwhelming that even if you combine the entire corn harvests of China and Brazil, it would barely keep pace with the US. Yet beyond the staggering numbers, corn has always been a quiet part of our everyday lives. We grew up nourished by sweet cereal at sunrise and golden canned corn come supper time. Simple comforts that fed not just our bodies, but the tender memories of a simpler world. Compared to potatoes, corn is nearly twice as affordable and yet richer in nutrition, boasting higher levels of protein, fiber, and vitamin B9, along with lutein and zeaxanthin. However, with the emergence of genetically modified corn varieties in the late 20th century, a wave of concern spread among millions of consumers about the potential risks of cancer. That said, the majority of GMO corn today is field corn, used for livestock feed, ethanol production, and industrial products. While sweet corn, the type we typically enjoy fresh, canned, or frozen, is rarely genetically modified. This has been a common misconception that has persisted for decades. Setting controversies aside, the journey of sweet corn has never truly ended. Every July, as the corn silks dry up and the fields turn golden, it signals the arrival of a bustling harvest season. And it's also when the farmers' daughters, along with their mighty machines, gear up for the harvest. First, for full-ear corn harvesters, the machines glide smoothly down each row of corn, using sharp blade systems, either serrated or rotary, to cut the stalks cleanly at the base and pull the entire plant into the machine. Inside, counter-rotating rollers handle the next step. They strip away the outer leaves, retain only the quality ears of corn, and send them up a conveyor belt into a holding tank or directly into a transport truck. Meanwhile, the leftover stalks, husks, and leaves are blown out the back by a high-powered fan, balling onto the field to serve as natural mulch or raw material for composting. While combine harvesters for field corn focus on shelling kernels efficiently for industrial use, sweet corn harvesters prioritize handling each ear gently, ensuring the kernels remain plump, juicy, and visually perfect for fresh markets and premium processing. A high-capacity harvester can process up to 15 to 20 tons of corn per hour, equivalent to the output of over 100 manual laborers working non-stop. Yet, as modern machines gradually replace human hands, the question of whether we should return to the fields, to sow and tend the land ourselves instead of relying entirely on machines and chemicals, remains open, touching on the preservation of original flavors and the enduring life of our planet. Another version of harvesting focuses on silage corn, corn grown specifically for livestock feed. Unlike sweet corn or field corn harvested for human consumption, silage corn is harvested while the entire plant is still green and rich in moisture. Specialized forage harvesters cut the whole stalk, chop it into small pieces, and blow the chopped material into large trailers. Afterward, the chopped corn is packed tightly into silos or bunkers, where it undergoes a natural fermentation process to become silage, a nutrient-rich feed that helps nourish hundreds of thousands of happy cattle across vast farms. Although technology has advanced significantly, it is the diligent hands of workers that still bring a level of superior quality that machines cannot replicate. Manual harvesting, although far less efficient than modern machines, operating up to 15 times faster, preserves the natural integrity and quality of each ear, ensuring they reach the next stage in perfect condition. With the fields harvested and the golden kernels carefully collected, the journey now moves from the sunlit farms to state-of-the-art factories, where sweet corn is about to be transformed into the delicious products we enjoy every day. After harvesting, different types of corn embark on separate journeys depending on their final purpose. Some destined for sweet canned corn, others for delicious popcorn. Although both journeys start with corn kernels, the variety used for making popcorn, known as Zea mays averta, is a distinct type of flint corn, quite different from sweet corn. At world-renowned popcorn factories like Orville Redenbacher's and the premium Dianen Gourmet popcorn, the process begins by preparing a rich blend of carefully selected ingredients. Although never officially disclosed, the secret formula behind perfect popcorn is believed to follow a mixture typically consisting of about 20% melted butter, 30% cooking oil, 45 to 50% sugar, and a small portion of other flavorings. Next, the dried corn kernels are fed into the popping chamber, where the machine heats up and builds pressure in preparation for the signature popping process. When the temperature reaches around 180 to 200 degrees Celsius, the kernels begin to burst simultaneously, releasing a sweet aroma and forming their light. In popcorn production, there are two distinct methods. Caramel popcorn is coated during the popping process itself, while other flavored varieties, such as cherry, cheese, or chocolate, are first popped plain and then coated with their respective flavors afterward. After being separated, the popcorn, whether plain or caramel coated, moves into a centrifugal cooling drum where it is rapidly cooled and stabilized. This spinning process also removes broken kernels and excess caramel, ensuring that every finished popcorn piece is crisp, perfectly shaped, and consistently uniform. To enhance the product's appeal, Dianen Gourmet popcorn introduces an additional color coding step, giving the popcorn its final vibrant look. The coating drum gently tumbles the popcorn for about 4 minutes, allowing the colorful layer to fully adhere without compromising the crunch, preparing each piece for the next stage of processing. After achieving its final color and flavor, the popcorn is transferred to the automated packaging area. Once packed, the finished products are neatly boxed, sealed, and moved to storage, ready to make their way to millions of sweet-toothed fans around the world. While popcorn brings bursts of flavor to lively movie nights, sweet canned corn holds the golden secrets behind the beloved cans enjoyed by billions. Secrets that we are about to uncover. After passing the inspection stage, the qualified ears of corn are sent directly to the automatic husking machine. This equipment uses a system of rollers and high-speed rotating blades to efficiently strip away the outer husks and silk in just a few seconds without damaging the kernels inside. Thanks to sensors that precisely control cutting force and rotation speed, the machine ensures each ear of corn is handled gently yet thoroughly. Immediately afterward, the corn is passed through a high-pressure spray chamber, where clean water jets continuously from multiple directions. While high-pressure washing effectively removes dirt, debris, and surface residues from the corn, it does not completely eliminate pesticides that may have penetrated into the kernels. Therefore, strict control of farming practices and careful sourcing of raw materials are essential to ensure safe, high-quality products. For canned corn production, after husking, the ears are not packed whole, but are instead sent to a specialized kernel removal machine. This machine uses rotating blade shafts and compression rollers to quickly separate the kernels from the cob while preserving their shape and preventing damage. The separated kernels then fall onto a vibrating conveyor, where they are evenly spread out and gently moved forward for further cleaning and processing. The golden corn kernels are then passed through another round of clean water washing, combined with vibrating conveyors and multi-directional spray nozzles for about 2 to 3 minutes, thoroughly removing any leftover husk fragments, undersized kernels, dust, and impurities from the separation process. But don't be mistaken, this process does not significantly cause nutrient loss, as most of the corn's key nutrients are contained within the kernels and are not easily dissolved in water. After thorough washing, the corn kernels are transferred into a blanching machine using either hot steam or circulating boiling water. The blanching process lasts only about 1 to 2 minutes, but plays a critical role. It gently softens the kernels, inhibits spoilage enzymes, and helps preserve their crisp texture and natural golden color. Immediately after blanching, the corn is discharged onto a quick cooling system, typically using cold water at around 2.5 degrees Celsius to rapidly bring down the temperature. This sudden temperature shift helps maintain the kernel's firm structure and prepares them for the filling stage without allowing further cooking. Meanwhile, to ensure even cooling and prevent clumping, the kernels are gently moved across vibrating conveyors submerged in cold water. Although it may seem similar to freezing, this rapid cooling is a precise control step, a race against time to preserve the corn's crisp texture, vibrant color, and natural sweetness, ready for the final transformation. Once cooled, the corn kernels are transferred to an automatic filling machine, where they are dispensed into pre-sterilized cans. Depending on the product line, the cans may also be filled with a light brine or a mild corn syrup solution to help preserve freshness and enhance flavor. The light corn syrup used in canned corn is not harmful, as it primarily helps enhance flavor and preserve freshness, while health concerns are generally associated with the excessive consumption of high-fructose corn syrup found in heavily processed foods. Immediately afterward, the cans pass through a vacuum sealing machine, which removes excess air before sealing them tightly with tin lids. After sealing, the cans move into a high-pressure steam chamber for sterilization, where the temperature is kept between 115 to 121 degrees Celsius to extend shelf life. Without sterilization, canned corn could only be preserved for a few days under refrigeration, but with proper sterilization, it can be safely stored for up to 1 to 2 years at room temperature. After sterilization, the cans of corn are rapidly cooled using a circulating cold water system to maintain the structural integrity of the cans and stabilize the quality of the product inside. The cans then move along an automatic labeling line, where product information, barcodes, production dates, and expiration dates are accurately printed and applied, ready to deliver their natural sweetness to soothe millions of hearts. And so, from the sun-drenched fields of Iowa to the neatly sealed cans on our tables, The journey of sweet corn is a story of patience, craftsmanship, and the quiet dedication of farmers, and of the enduring spirit of a grain that has nourished the world for generations. As you savor that sweet, familiar taste, remember, you're not just enjoying corn. You're holding a tiny piece of the world's golden grain legacy. Thank you for joining us on this journey. Stay curious, stay inspired, and the next chapter of Agriculture Insight is coming right up. Potatoes are primarily grown in Idaho and Washington, the two leading states in potato production in the United States. In 2024, the U.S. produced approximately 19 million tons of potatoes, with around 12 million tons processed for various purposes. In the U.S., potatoes are typically harvested in the fall from August to October. First, the potato harvester is activated, using a system of sharp blades to cut into the soil just beneath the potatoes and gently lift them to the surface. As the potatoes are brought up, dirt and debris are removed through integrated vibrating screens or conveyor belts. The potatoes are then neatly arranged in rows on the ground, ready for other machinery to pick them up and continue the processing. Next, a potato gathering machine moves along the rows of freshly unearthed potatoes. Using a system of conveyor belts and sieves, it carefully picks up the potatoes while filtering out remaining soil, rocks, and debris. The potatoes are gently transferred onto the conveyor system within the machine to prevent bruising. As the machine moves, it coordinates with a truck traveling alongside, seamlessly transferring the cleaned potatoes into the truck's storage compartment. This process ensures that the potatoes are handled efficiently and remain in excellent condition. Once loaded, the truck takes the potatoes to the next stage of sorting or processing. On a 25-acre farm in the U.S., the average potato yield is about 16 to 20 tons per acre, totaling around 400 to 500 tons for the entire farm. With modern potato harvesters capable of handling 5 to 10 acres per day, it typically takes about 2.5 to 5 days to harvest the entire field, depending on soil conditions and the efficiency of the equipment. This time can be shortened further if multiple harvesters are used, ensuring a quick and efficient harvest. Each harvest season brings bustling activity to the fields, filled with the hum of modern machinery working tirelessly. After the harvest, trucks transport the potatoes to a central storage facility where they are carefully unloaded and prepared for the next stages. At the storage facility, trucks unload the potatoes onto modern conveyor belts positioned at the entrance. These conveyor systems efficiently transport the potatoes into the storage area while gently handling them to prevent damage. As the potatoes move along the belts, built-in filters and separators allow dirt, dust, and small rocks to fall through to a secondary conveyor system below. This secondary belt carries the debris to a designated waste collection area, ensuring that only clean potatoes make their way into storage. Afterward, the conveyor belts continue to transport the potatoes into the storage facility, where they are carefully deposited in massive piles. These modern conveyor systems save a tremendous amount of time and labor, streamlining the entire process. As the potatoes steadily flow in, they form what can only be described as a true mountain of potatoes, ready to be sorted, processed, or shipped. From these storage facilities, the potatoes are purchased by potato chip manufacturers and transported to processing plants, where they begin their transformation into crispy, golden snacks loved by millions. The potatoes are first placed into large tanks filled with water, where any remaining dirt, rocks, or debris are gently washed away. The soil clinging to the potatoes dissolves into the water, ensuring even the most stubborn residue is removed. As the potatoes are thoroughly cleaned, they float to the surface or are guided along by the flow of water. Once washed, the clean potatoes are transferred onto conveyor belts, which carry them seamlessly to the next stage of the process. After washing, the potatoes are transferred to a vibrating system designed to shake off excess water, leaving them dry. From there, they move into a size sorting system equipped with rollers and calibrated gaps. These rollers allow smaller potatoes to pass through, while larger ones are guided along a separate path. The potatoes are then sent to an optical sorting machine, where advanced cameras and sensors detect and remove any defective or discolored potatoes. Next, the potatoes are transferred to a peeling machine, which uses high-pressure water jets and rotating drums to efficiently remove their skins. The combination of water pressure and mechanical rotation ensures that the peels are stripped off quickly and evenly without damaging the potatoes. After peeling, the potatoes are sent to a manual sorting station, where workers inspect and remove any remaining defects or imperfections. Next, the potatoes are fed into an automatic slicing machine, where they are cut into perfectly thin and uniform slices, ensuring the ideal thickness for crispy chips. Once sliced, the potato slices are gently moved along streams of water, which help to separate them and prevent sticking. As they flow through the water channels, they pass over vibrating sieves that remove any broken pieces or imperfections, ensuring only high-quality slices continue in the process. This careful handling maintains the integrity of the slices and prepares them for the next stage in the production line. These potato slices are deep-fried in oil for about 3 to 5 minutes, ensuring they achieve the perfect golden color, crispy texture, and rich flavor that make them irresistible. The potato slices continue their journey on large conveyor belts, where they are simultaneously cooled and drained of any excess cooking oil. As they move along the conveyor belts, fans or air systems are often used to speed up the cooling process while gently removing any lingering oil. This careful handling ensures that the chips maintain their crispy texture and are perfectly prepared for seasoning and packaging in the subsequent stages. The potato chips are then transferred to the seasoning machine, where they are coated with a variety of spices and flavors, according to the specific recipe of each factory. The system uses rotating drums or circular tumblers to gently toss the chips, ensuring every piece is coated with the perfect amount of seasoning. This process not only enhances the flavor, but also ensures consistency, giving each chip the signature taste that customers love. After being seasoned, the chips are transported to a packaging machine, where they are carefully portioned into precise amounts for each bag. The machine uses automated weighing systems to ensure that every bag contains the exact quantity specified, maintaining consistency and minimizing waste. Once measured, the chips are funneled into bags, which are then sealed tightly to preserve freshness and flavor. Afterward, the bags of potato chips move along the conveyor belt to the packaging area, where they are neatly placed into sturdy cardboard cartons. These cartons are then sealed and labeled, ensuring the chips remain fresh and protected during transit. Once packed, the cartons are transported to the storage area, where they are organized and prepared for shipping. From there, they are ready to be delivered to consumers. Let's continue the journey to the McCain Foods factory, a major supplier that provides a significant percentage of French fries to McDonald's restaurants worldwide. At this facility, the process for turning potatoes into French fries is nearly identical to making potato chips up to the peeling stage. It all begins with washing the potatoes thoroughly to remove dirt and debris, followed by the same precise peeling process using high-pressure water jets and rotating drums. These steps ensure that the potatoes are perfectly cleaned and peeled, setting the foundation for the next steps in creating those iconic golden fries. Next, the peeled potatoes are fed into automatic cutting machines, where they are precisely sliced into the iconic French fry shape. These machines ensure consistency in size and thickness, which is essential for even cooking and that signature crisp texture. After being cut, the potato strips are transported on vibrating systems that serve a dual purpose. These systems effectively remove any small fragments or irregular pieces while also preventing the strips from sticking together. This ensures that only uniform, high-quality fries move forward in the process, ready for even cooking. The potato strips then go through a blanching process, which typically lasts around 2 to 3 minutes using hot water or steam. This step helps to remove excess starch from the surface, ensuring a crispier texture when fried. Blanching also preserves the natural color of the potatoes and partially cooks them. After blanching, the potato strips are passed through an optical sorting machine equipped with advanced cameras and sensors. This system quickly identifies and removes any damaged, discolored, or misshapen fries. Next, the potato strips are dried to remove excess moisture before entering the frying stage. They are gently transported on conveyor belts during this process, where air or heat systems are used to ensure the fries are adequately dried. The potato strips then continue their journey into a deep frying tank, where they are immersed in hot oil for approximately 2 to 3 minutes. This step ensures they develop the perfect golden color, crispy exterior, and fluffy interior, creating the signature texture and flavor that French fries are known for. After frying, the potato strips are transferred onto conveyor belts designed to drain excess oil effectively. These conveyor belts are equipped with perforations or mesh surfaces that allow the oil to drip through, while gentle airflows or fans help cool the fries slightly and further remove residual oil. The conveyor belts are often equipped with a vibrating system that helps further shake off any remaining oil from the fries. This vibration ensures that the fries are evenly dried and prevents them from sticking together. They travel on cooling and chilling conveyors for nearly 2 hours to finalize their flavor and texture. Afterward, the fries are subjected to stringent quality checks in a laboratory setting to ensure they meet precise standards for taste, texture, and appearance. These tests also verify that the fries align with food safety regulations and meet McDonald's exacting specifications. The fries are then sent to an automated portioning machine, which carefully measures out precise amounts for packaging. This system ensures consistency in weight and quantity, meeting both quality standards and customer expectations. Once portioned, the fries are funneled into large, durable plastic bags designed to maintain their freshness during storage and transportation. The packaging machine seals the bags tightly to prevent contamination and preserve the product's quality. The sealed bags are placed into cardboard cartons on an automated conveyor system, ensuring efficiency and precision in the packing process. Each carton is carefully filled to the exact specifications, maintaining consistent weight and minimizing any risk of damage during transport. The cartons are then securely sealed and labeled, ready for storage or shipment to their final destinations. When the cartons arrive at McDonald's, employees simply take the pre-packaged fries from storage and fry them to golden perfection. This quick and efficient process ensures customers can enjoy delicious, crispy French fries every time. When the lush green fields of carrots begin to fade to a pale shade, it's a clear sign that harvest season has arrived. After 70 to 80 days of growth, the carrots reach their peak condition, with smooth, firm skins and a vibrant orange color. To ensure an efficient harvest and maintain the highest quality, farmers use advanced machinery that makes the process quick, precise, and labor-saving. The harvester they use is designed to handle the entire process, from lifting carrots out of the ground to basic cleaning and separating the leaves from the roots. The cutting blades at the base of the machine slice through the stems and gently lift the carrots out of the soil without causing any damage. Simultaneously, an integrated conveyor system moves the carrots upward, where dirt and debris are partially removed using fans and a vibration mechanism. Once the carrots are cleaned, the leaves are cut off and left on the field, reducing transport weight and returning organic matter to the soil. The cleaned carrots are then transferred directly into large bins on trucks moving alongside the harvester. This machine significantly improves efficiency, saving both time and labor compared to traditional manual harvesting methods. In some areas, a combined harvesting system with 2 machines is used. These machines work closely together to complete the process efficiently. The first machine removes all the carrot tops using a specialized cutting system that only removes the leaves without affecting the carrots underneath. The leaves are left on the field to improve soil fertility. The second machine uses deep cutting blades to gently lift the carrots from the soil without causing any damage. The cleaned carrots are then transferred onto a conveyor belt and moved directly into large bins on nearby trucks, while the soil is left behind in the field. This process ensures high-quality carrots, reduces costs, and increases overall harvesting efficiency. The use of advanced machinery in carrot harvesting has truly revolutionized American agriculture, prioritizing efficiency, quality, and sustainability. Modern harvesting machines with integrated features have made the process faster, more precise, and cost-effective than ever before. Additionally, high-tech machinery optimizes labor resources by freeing workers from physically demanding and time-consuming tasks. This not only lowers labor costs but also reduces pressure on workers, allowing them to focus on other important aspects like quality control or preparing for future crops. More importantly, the use of modern machinery brings consistency to the production process. Carrots harvested with advanced machines not only meet strict standards for shape and size, but also retain their freshness thanks to the quick and precise handling. This is especially critical in today's market, where quality demands are high, particularly in export markets that adhere to rigorous international standards. These machines ensure that every carrot from field to table meets consumer expectations with consistent quality. Beyond improving efficiency, high-tech machinery in carrot harvesting carries significant benefits for sustainable agriculture in the U.S. Automated systems reduce resource waste, limit emissions from transportation, and enhance soil regeneration. This demonstrates a clear synergy between science and practical farming, creating a production process that is both efficient and environmentally friendly. The use of advanced machinery also reflects the forward-thinking approach of American farmers in building a modern, competitive agricultural industry. They not only prioritize higher yields, but also focus on sustainable practices and innovation. These machines not only boost production capacity, but also allow farmers to dedicate more time to strategic tasks, such as developing better crop varieties or refining farming techniques. Now let's feel the most realistic harvesting processing with vivid sound. After harvest, carrots are transported to factory for further processing. At the factory entrance, carrots are unloaded from trucks onto a conveyor system, where they are gently and continuously moved along. The conveyor transports the carrots into large storage bins designed to protect the produce from damage. These filled bins are then quickly and efficiently transported into the factory by forklifts. This process not only optimizes time, but also preserves the freshness and quality of the carrots before they move on to the next stages of processing. Next, the carrots are transferred to a modern washing line. The carrot washing process in the factory begins with the carrots being transferred from the main conveyor to a specialized washing system. First, they pass through a large water tank equipped with high-pressure water jets that remove dirt and soil from the surface. Next, the carrots move through rotating drums or conveyors with soft brushes that scrub away any stubborn dirt without damaging their natural skin. The water used in this process is continuously filtered and recycled to ensure efficiency and environmental friendliness. Following this, the carrots are rinsed once more with clean water to ensure they are completely sanitized. Finally, they are gently dried on a conveyor before being moved to the next stages of processing. This meticulous process ensures that each carrot meets the highest hygiene standards before reaching consumers. After being thoroughly washed, the carrots are moved to a size sorting conveyor equipped with special rolling bars. These bars have gaps of varying sizes, allowing smaller carrots to fall through while larger ones continue along the conveyor. This process ensures precise sorting of carrots by size before they proceed to the next stages of processing. Next, the carrots are sent to an automated sorting system equipped with advanced sensors. These sensors scan each carrot to assess its size, color, and shape, then automatically sort them into appropriate categories. This process is not only fast but also highly accurate, ensuring optimal product quality before processing or packaging. After being sorted, the carrots are transferred to an automated packaging line. Here, they are precisely weighed to ensure the correct weight for each type of packaging. The carrots are then placed into bags or boxes, with the automated system sealing or closing them and applying product labels. Finally, the completed carrot packages are stacked onto pallets, ready for transportation to stores or distributors. Red beets typically take about 60 to 70 days to grow from seed to harvest. When the beets reach their ideal size, vibrant deep red color, and meet quality standards on the inside, the harvesting process begins. Farmers usually choose dry days for harvesting to ensure machinery operates efficiently and to minimize any negative impact on the soil. On the vast fields of the U.S., harvesting red beets has been fully automated with the support of modern machinery that works seamlessly to optimize each step of the process. First, a specialized machine trims the green tops of the beets as it moves gently along the rows. Its sharp cutting blades ensure a quick and precise operation, leaving the beet roots undisturbed beneath the soil. The trimmed leaves are immediately shredded and spread back onto the field, creating a natural layer of fertilizer that enriches the soil and helps maintain its fertility. Following this is a specialized harvesting machine designed to lift and collect the beets. Equipped with automatic gripping mechanisms, it carefully removes the beets from the ground, minimizing any damage to their surface. The soil clinging to the beets is then gently removed through an integrated shaking or air-blowing system. The cleaned beets are transferred onto an automatic conveyor belt, which moves them directly into large storage bins on trucks moving alongside the field. Both machines work in perfect harmony, like a well-orchestrated assembly line, ensuring a fast and efficient harvest while maintaining the quality of every beet. In addition, many farms use advanced multifunctional harvesters that combine multiple tasks into one seamless process. These machines handle 3 critical steps simultaneously: lifting the beets, processing the leaves, and performing preliminary cleaning. Once the beets are lifted from the soil, the integrated cutting system trims the leaves instantly. The leaves are then shredded and returned to the field to enrich the soil with organic matter. The beets are cleaned on the spot and transferred directly into the machine's storage bins. A standout feature of this harvester is its ability to automatically monitor the bin's weight, optimizing the transport process. When the bin reaches its maximum capacity, the system automatically shifts the beets onto a conveyor that transfers them to a nearby truck, ensuring the workflow remains smooth and uninterrupted without the need for manual intervention. Modern machinery is more than just a tool. It's a game changer in the way red beets are harvested, delivering exceptional efficiency for farmers. These advanced machines save time and labor while ensuring every beet meets the highest standards of size, color, and quality. The seamless integration of steps, from leaf trimming and beet lifting to preliminary cleaning, allows the harvesting process to be both fast and precise, minimizing waste and loss. Beyond boosting productivity, modern machinery plays a crucial role in promoting sustainable agriculture. Let's see how modern machines work with vivid sounds right now. After harvesting, the trucks, loaded with freshly harvested red beets, transport them to collection centers, where the beets are gathered and prepared for processing at nearby factories. Consolidation helps the factory process red beets more efficiently, avoiding overload or interruption in the production line. Consolidation also helps preserve beets in suitable conditions, limiting damage and ensuring freshness. From the pile of red beets gathered, the red beets continue their journey at the processing plant. At processing facilities, red beets go through a professional and meticulous procedure to ensure the highest quality before reaching consumers. The red beets are first transported along conveyor belts, where dirt and dust are gently shaken off to ensure they're clean and ready for the next stage. Afterward, workers manually sort the beets to ensure only high-quality ones proceed to the processing stage. They are thoroughly washed using high-pressure water jets to remove dirt and impurities. Beets are moved to an automated packaging line, where they are carefully packed into mesh bags, allowing airflow to maintain their freshness and vibrant color. In another factory, red beets are peeled and packaged directly for consumers to use. Peeled and vacuum-packed red beets offer numerous outstanding benefits. The pre-processed product saves consumers time and makes it convenient for immediate use. The vacuum sealing process not only preserves the freshness and natural, vibrant color of the beets, but also retains essential nutrients like vitamin C and folate. Additionally, the extended shelf life without the need for preservatives, along with guaranteed food safety standards, makes this product a convenient and reliable choice for both households and food processing facilities. Peeled and vacuum-packed red beets offer numerous outstanding benefits. The pre-processed product saves consumers time and makes it convenient for immediate use. The vacuum sealing process not only preserves the freshness and natural, vibrant color of the beets, but also retains essential nutrients like vitamin C and folate. Additionally, the extended shelf life without the need for preservatives, along with guaranteed food safety standards, makes this product a convenient and reliable choice for both households and food processing facilities. Additionally, red beets are often processed into salted varieties. The process involves carefully slicing or preparing the beets before salting them with a controlled amount of high-quality brine. This modernized system ensures uniform salting, maintains the vibrant color of the beets, and meets strict hygiene standards, resulting in a premium product ready for distribution. The production line for salted beetroot is equipped with state-of-the-art machinery designed for precision and efficiency. Next, let's dive in the story of another beet, sugar beet. While the journey of red beet from harvest to packaging showcases its culinary versatility, the story of sugar beet takes us into a world of sweetness, where these humble roots are transformed into one of the most essential ingredients in our daily lives. This is sugar. Typically, it takes about 7 to 8 months for sugar beets to mature and be ready for harvest. When the time comes, American farmers employ modern machinery to harvest the crops. These machines allow for quick and efficient harvesting while ensuring the quality of the produce. As the harvest season begins, the vast sugar beet fields are bustling with specialized machinery tasked with the job. These harvesters are specifically designed for precise and optimal extraction of sugar beets. The harvesting process begins as the machine enters the field where the sugar beets have matured. Sugar beet harvesters typically feature a sharp, controlled cutting system that digs deep into the soil to separate the beet roots from the ground. This digging component can cut and lift the beets without breaking them or harming the soil. Once lifted, the beets are transferred to a conveyor belt that moves them to the cleaning units. Moreover, the harvesting of sugar beets is made more modern and efficient through the use of 2 specialized machines. First, a large harvester moves across the field, using powerful cutting blades to remove all the foliage from the sugar beets. This machine separates the leaves from the roots, preparing them for the main harvesting phase. Following this, another machine equipped with special mechanisms passes over to lift the beets from the ground. The beets are placed on a conveyor belt where they undergo preliminary cleaning, removing soil and any remaining impurities. This process ensures the beets retain their best quality. Finally, the cleaned beets are transferred to a truck parked near the field, ready to be transported to the processing facility. Once all the beets have been consolidated, the remaining tasks are performed at the processing plant. This is where a closed-loop process transforms the raw, muddy beets into pure sugar granules, ready to meet consumer and production demands. The process is carried out with the support of advanced technologies and modern machinery, ensuring optimal efficiency and the highest quality. First, the cleaning stage begins. The sugar beets in the consolidation area are moved on a conveyor belt to an automatic washing system. Here, strong water jets directly spray the beets, combined with rotating drums and conveyors, helping to remove dirt, rocks, and other impurities from the surface. Next is the slicing stage, an important step in the processing. Modern slicing machines with sharp blades cut the beets into thin strips, called cassettes. These strips have a greater surface area, facilitating the sugar extraction process. The cassettes are then placed in large extraction tanks, where water heated to about 70 degrees Celsius circulates to dissolve the natural sucrose in the beets. The result is a raw juice with a high sugar content that is collected and moved to the refining stage. This solution is transferred to an evaporation tower, where excess water is removed, increasing the sugar concentration. Evaporation towers often use vacuum technology to reduce the boiling temperature and protect the quality of the sugar. Once the solution reaches a certain concentration, it is moved to a crystallizer. Here, small seed crystals are added to help the sugar crystallize and grow into the desired crystal size. After crystallization, the sugar crystals are still coated with a layer of molasses, giving them a golden hue. They are placed in a centrifuge, where they are spun at high speeds to separate the molasses from the sugar crystals. The molasses is often used as a raw material for other products, while the sugar crystals proceed to the drying stage. Drying equipment uses hot air to dry the sugar, ensuring each crystal meets standards for moisture content and purity. Once the sugar is dry, it is moved to an automatic packaging system. Depending on its intended use, the sugar may be packaged in small bags for household use or large sacks for the food industry. For liquid sugar, such as syrup, specialized bottling lines handle the bottling process, ensuring each bottle is securely sealed and safe. So that's it for the journey of 2 beets. Thanks for taking the time to join me on this journey. Don't forget to like and subscribe to the channel. See you in the next video.